Hello everyone, in this video we are going to discuss about kinematics in one dimension. In kinematics, we will deal with the description of the motion without considering the causes of the motion. Next, we need to know what displacement is. Displacement is the change in position from one point to another point. We use the formula final position minus initial position. So, let's watch a video and apply the formula. The situation in this video is Shuki moved to the right 7 units and 2 units to the left in 3 seconds. So, let's say 7 units is equal to 7 cm and 2 units is 2 cm. The question is, what is the displacement of Shuki? So, we use the formula final position minus initial position. Then, we substitute the values to the formula. So, 7 minus 2 equal to 5 cm. You might have the thought of the difference between distance and displacement. Distance is total length travel, while displacement is total length travel in particular direction. So, referring to the example before, the distance traveled by Shuki is 7 cm plus 2 cm. So it is equal to 9 cm without considering the direction of Shuki. And the displacement of Shuki is 7 cm to the right plus negative 2 cm because Shuki is moving to the left. So the displacement of Shuki is 5. From here, we know that distance is a scalar quantity while displacement is a vector quantity. Next, we need to know how to find the speed of an object. Speed is distance divided by time taken, while velocity is displacement divided by time taken. The difference between these two is we can know the direction of the motion of object by finding the velocity of the object. Again, referring to example before, Shuki moving to those points in 3 seconds. The question is, what is the speed and the velocity of Shuki? We can simply substitute the information we have. For speed, distance divided by time. So, 9 cm over 3 seconds, we got 3 meter per second. For speed. For velocity, displacement divided by time, that is 5 cm over 3 seconds. So, we got 1.97 meter per second. The next thing you need to know is how to find the average velocity. So the average velocity is displacement, that is final position minus initial position divided by particular time taken, that is t2 minus t1. Next, constant velocity meaning velocity at any particular time is same. For instantaneous velocity is the average velocity in the limit as the time interval become infinitesimally small. You can find the instantaneous velocity by differentiate the displacement equation. Next is acceleration. Acceleration is rate of change of velocity. We can find the acceleration or average acceleration by find the difference of velocity and divide it with t2 minus t1, that is the difference of time taken. The unit of acceleration is meter second negative 2. In one dimension, the positive and negative value of acceleration can indicate the direction. For instantaneous acceleration, that is average acceleration in the limit of time interval. To find instantaneous acceleration, we need to differentiate the velocity equation. So the next part, we move on to kinematics equation that is known as SUVAT, S-U-V-A-T. So the S is displacement, U is initial velocity, V is final velocity, A is acceleration, and T is time taken. So these are the basic three equations of kinematics. V is equal to U plus AT, V squared is equal to U squared plus 2AS, and S is equal to UT plus half AT squared. One of the example of kinematics is free falling body. So free fall is the motion of a body where gravity is the only force acting upon it. In kinematics, we have three situations that free fall may occur. First situation of free fall is when the object is dropped. The information we got is the initial velocity is 0 and the acceleration is negative 9.81 meter per second squared, that is gravitational acceleration. The second situation of free fall is when the object is thrown downward. The initial velocity is not equal to 0 and the acceleration is the gravitational acceleration, that is negative 9.81 meter per second squared. And the third one is when the object is thrown upward. The initial velocity is not equal to 0, that means velocity exists at initial point. And the velocity at the maximum height is 0 because the object is stopped temporarily. And the last one is also the acceleration acting on the object is negative 9.81 meter per second squared. Let's watch the video to apply the formula. Let's assume the bed is a building. The situation is Shuki is dropped from the building in 2 seconds. The question is, what is the height of the building? The information that we got from the question are the Shuki is dropped, meaning initial velocity is equal to 0. In 2 seconds, that is the time taken of Shuki, and the gravitational acceleration, that is negative 9.81 meter per second squared, that is a constant. And the height of a building, meaning the displacement of Shuki after it dropped. So the first thing you need to do is determine which formula we can use from the three kinematics equation with the information that we got. So here we got the U, the T, and the A, and we need to find the S. We can use the S is equal to UT plus half AT squared equation. Then we move on to the second step, that is substitute the values into the formula. So S is equal to 0 multiplied with 2 plus with half of negative 9.81 multiplied with 2 squared. And then you calculate with your calculator, you will get negative 19.62 meter. The negative sign indicates that Shuki is going downward. Hope you guys got something in this video, and thank you for watching. Bye.